Imagine a world so alien, so profoundly dark, that the very concept of life is redefined. Far beyond the reach of sunlight, under pressures that would crush a submarine, lies an Earth you've never seen. Before we dive into this hidden world, don't forget to subscribe to StarSky Science, your gateway to the mysteries of our universe, our planet, and the astonishing frontiers still left unexplored. When most people think of Earth, they picture landscapes shaped by light, forests glowing green under the sun, deserts stretching like golden seas, mountains dusted in snow touching the clouds. But the truth is, these places, beautiful though they are, make up only a fraction of our planet. In reality, more than 70% of Earth's surface is covered by ocean, and most of that ocean lies in perpetual night. This is the deep ocean, a world hidden beneath the waves, where sunlight cannot reach, and where life has evolved in ways that defy imagination. It is a world larger than all the continents combined, and yet, it remains more mysterious than the surface of Mars or the icy moons of Jupiter. Scientists estimate that more than 80% of our oceans remain unexplored. That means, for every creature we have discovered, there could be dozens more waiting in the dark, bizarre, alien, and utterly unknown. Why does this matter? Because the ocean is not just a vast body of water. It is the heart of our planet. It regulates the climate, absorbs carbon dioxide, generates the oxygen we breathe, and sustains the web of life that includes us. If we ignore it, we ignore Earth itself. And if we lose it, we lose the future of humanity. So tonight, we descend. Together, we will leave behind the sunlit surface and travel into the abyss. We will explore the twilight zone, the midnight zone, and finally, the hadal trenches, the deepest parts of the ocean, deeper than Mount Everest is tall. Along the way, we will encounter creatures that bend the very definition of life, ecosystems powered not by sunlight, but by heat from the Earth's core, and forces so immense they shape the geology of our entire planet. Our descent begins just below the surface. Here, in the upper 200 meters, sunlight still penetrates. This zone is rich with life. Phytoplankton drift in shimmering clouds, tiny plants that produce more than half of the oxygen in our atmosphere. Schools of fish move like liquid silver, pursued by dolphins, sharks, and seabirds diving from above. It is a realm we know well, because it is the one closest to us. But beneath this, everything changes. At 200 meters, the light begins to fade. Reds and oranges disappear first, then yellows. By 500 meters, the ocean turns blue-green twilight, and then finally, black. This is the mesopelagic zone, also known as the twilight zone. It is here that life adapts to the vanishing light with one of the astonishing tricks of evolution, bioluminescence. Bioluminescence is not rare in the deep. In fact, it is the rule rather than the exception. An estimated 90% of the animals here produce their own light. The process is chemical. Luciferin, a light-producing molecule, reacts with oxygen in the presence of an enzyme called luciferase. The result? A living lantern. Some creatures emit constant glows, while others flash in pulses like underwater fireflies. For them, light is survival. It can attract prey, confuse predators, or signal mates. Take the lanternfish, one of the most abundant vertebrates on Earth. These small fish possess rows of glowing photophores along their sides, shimmering like runway lights. At night, billions of them rise toward the surface to feed, in what is called the diel vertical migration, the largest migration of life on Earth, happening every single day. At dawn, they return to the depths, carrying the energy of the surface down into the twilight zone. Without them, much of the deep ocean's food chain would collapse. And then there are predators. The anglerfish is perhaps the most iconic. With its grotesque jaws and needle-sharp teeth, it seems terrifying. But it is the glowing lure protruding from its forehead that makes it a true master of deception. A tiny orb of light dangles in front of its mouth, hypnotizing smaller fish. They swim towards it, believing they've found food. In reality, they've entered a trap. With a single snap, the anglerfish swallows its victim whole. But survival here is not just about hunting. It is also about hiding. Some fish use light to disappear. This is called counter-illumination. By glowing on their undersides, they match the faint light filtering from above, making their silhouettes vanish against the dim background. In the twilight zone, invisibility is often the best defense. Yet the twilight zone is only the beginning. Below 1,000 meters, no sunlight can penetrate. This is the bathypelagic zone, or midnight zone. Here, the pressure is immense, more than 100 times what you feel at sea level. The water is near freezing, around 4 degrees Celsius. And yet, even here, life exists, strange, ghostly, and resilient. The gulper eel, for instance, is a creature of nightmare. Its jaws can unhinge to swallow prey half its size. Yet its body remains thin, almost fragile, like a ribbon. Or the fangtooth, with teeth so large they can't fit in its mouth. At just 16 centimeters long, it looks like a demon, but it is a survivor, capable of living at depths greater than 5,000 meters. But perhaps the strangest of all are the deep-sea jellies. These gelatinous drifters come in shapes that defy description. Glowing bells, long trailing tentacles, even living chandeliers of light. They pulse through the darkness, delicate and deadly, some with stingers powerful enough to paralyze fish instantly. Unlike the predators of the surface, which rely on speed and strength, these creatures survive by patience, stealth, and an elegance born of the abyss. Deeper still, we enter the abyssopelagic zone, 4,000 meters down. Here, the ocean floor begins to appear. Flat plains stretch endlessly, broken only by the occasional seamount or ridge. Few animals roam here, but those that do are uniquely adapted. The tripod fish, for example, balances on elongated fins like stilts, waiting motionless for food to drift by. At this depth, energy is scarce, so creatures must conserve it with extraordinary efficiency. At 6,000 meters and beyond, we reach the hadal zone, named after Hades, the underworld. These are the ocean trenches, some plunging more than 11 kilometers deep. The Mariana Trench in the western Pacific is the deepest known point on Earth, called Challenger Deep. To stand at its bottom is to be under the weight of nearly 50 jumbo jets pressing on every square inch of your body. And yet, life is there. Amphipods, shrimp-like crustaceans, crawl along the mud. Microbes thrive in the sediments, and giant single-celled organisms, called xenophytophores, grow as large as grapefruits, surviving in silence where no light has ever reached. These trenches are more than just deep scars in the ocean floor. They are geological engines where Earth recycles itself. At trenches, tectonic plates collide and one plate sinks beneath another in a process called subduction. This drives earthquakes, fuels volcanoes, and even builds mountains. In other words, the story of the deep ocean is the story of Earth's living, breathing surface. But perhaps the most astonishing discovery of the deep came not in the trenches, but along the mid-ocean ridges. In 1977, a team of scientists exploring the Galapagos Rift stumbled upon something unimaginable: hydrothermal vents. Here, seawater seeps into cracks in the Earth's crust, is superheated by magma and erupts back into the ocean as black plumes rich with minerals. The water is toxic, acidic, and hot enough to boil, and yet, around these vents thrived ecosystems more lush than anyone had ever dreamed. Towering tube worms with blood-red plumes, giant clams, blind crabs, and swarms of shrimp clustered around the chimneys, feeding not on sunlight, but on chemistry. At the base of this food web are chemosynthetic bacteria, organisms that harness energy not from the sun, but from chemicals like hydrogen sulfide. This discovery revolutionized our understanding of life. For the first time, we realized that ecosystems could exist entirely independent of the sun. Life could arise wherever there is energy, even in the dark.
As we leave the twilight and midnight zones behind, we descend into an even stranger world, the abyss. Here, at depths between 3,000 and 6,000 meters, sunlight is not just dim, it is gone completely. Darkness becomes absolute. The water is near freezing, often just above 0 degrees Celsius, and the pressure is enough to crush steel. And yet the seafloor spreads out into vast plains, flat and featureless at first glance, but hiding life forms that stretch the imagination. The abyssal plains are sometimes called the great deserts of the ocean because food is scarce here. Most of what sustains life at these depths falls from above, drifting down through the water column like marine snow. Tiny fragments of dead plankton, fish, and organic debris slowly sink, forming a thin but steady rain of nutrients. Without this snowfall of life from the surface, the abyss would be a wasteland. But instead, it supports bizarre communities of creatures that have evolved in silence for millions of years. Imagine a sea cucumber lying motionless on the sea floor. At first, it looks like a blob of jelly, barely alive. But watch closely and you'll see it sift particles from the mud, extracting every trace of nutrition from the ocean's dust. In the abyss, nothing is wasted. Giant isopods, relatives of the pill bugs we find on land, grow to the size of dinner plates here, scavenging any corpse that drifts down. When a whale dies and its body sinks to the bottom, it becomes an oasis of life in the abyss. Whole communities gather to feast on the whale fall: hagfish, crads, snails, worms, and eventually bacteria that strip even the bones clean. In the dark, every death becomes a gift of survival. But not all is still in the abyss. Across these plains, the earth itself sometimes breaks through. Volcanic ridges snake across the ocean floor, releasing heat and minerals into the cold blackness. At these sites, called hydrothermal vents, something extraordinary happens. Instead of sunlight driving life, chemical energy takes over. Minerals rich in sulfur and metals gush into the water, mixing with the icy ocean around them, forming black chimneys known as smokers. To us, this is a place of hellish extremes. To life, it is a paradise. Here, tube worms grow taller than a human, with blood-red plumes that capture chemicals instead of light. Giant clams and ghostly crabs cluster in the mineral-rich water. Entire ecosystems thrive without the sun, feeding on bacteria that convert chemistry into energy through a process called chemosynthesis. For many scientists, these vents are more than just strange curiosities. They may be the birthplace of life itself. Billions of years ago, when Earth was still forming, vents like these could have provided the spark and the chemistry needed for the first living cells. And if that is true, then perhaps similar vents on other worlds, on the icy moons of Jupiter and Saturn, could also host life in their hidden oceans. Now we descend further into the hadal zone, named after Hades, the Greek underworld. These are the ocean trenches, plunging deeper than Everest is tall. The Mariana Trench, the deepest of them all, reaches nearly 11 kilometers down. At this depth, the pressure is over 1,000 times greater than at sea level. No light, no warmth, only crushing darkness. For centuries, scientists assumed nothing could survive here. And yet, when submersibles and robotic probes finally made the journey, they discovered life waiting. Small amphipods, shrimp-like creatures, dart through the black water. Transparent snailfish, their bodies fragile and delicate, glide across the trench walls. Their bones are reduced, their organs adapted with special molecules that keep proteins from collapsing under pressure. They are, in every sense, perfectly built for a world that should be impossible. Even bacteria thrive here, feeding on chemicals leaching from rocks and sediments. Some of these microbes can digest pollutants, like oil, hinting at potential uses for cleaning Earth's surface environment. Consider what this means. Even in the most hostile corners of our planet, life refuses to surrender. If Earth's deepest trenches can harbor such resilience, then what might be possible in the oceans beneath Europa's icy crust, or the hidden seas of Enceladus? Our own planet's extremes may be the key to understanding life beyond Earth. For humans, reaching these depths has been a monumental challenge. In 1960, the Trieste, a bathyscaphe piloted by Jacques Piccard and Don Walsh, became the first manned vessel to touch the bottom of the Mariana Trench. They reported seeing a flatfish-like creature swim past their viewport, though later debate questioned the sighting. Still, it proved that life was present, even at the ocean's ultimate depths. Decades later, filmmaker James Cameron made a solo descent in his deep-sea Challenger, spending hours exploring the trench floor. Robotic probes like Japan's Kaiko and China's Fenduza have followed, capturing images of alien-like landscapes in crushing blackness. Each mission reveals more, but each also reminds us of how little we know. Yet as we explore, humanity is beginning to see the deep, not only as a frontier, but as a resource. Beneath the abyssal plains lie fields of manganese nodules, potato-sized lumps rich in metals like cobalt, nickel, and copper. These are the very elements needed for batteries, electronics, and the technologies driving the modern world. Mining companies see wealth on the ocean floor, but scientists warn that disturbing these fragile habitats could destroy species we have not even discovered yet. The deep ocean is a slow world. Life grows at an agonizing pace, and a wound here could take centuries to heal. To strip the abyss for profit is to gamble with a realm that regulates our climate, absorbs our carbon, and supports our surface survival. It is easy to forget that the ocean is not just water. It is a living system, a machine of currents and chemistry that makes Earth habitable. The abyssal circulation carries oxygen into the depths and brings nutrients back up. When climate change alters these flows, the deep feels it first. Warming waters reduce oxygen, acidification dissolves shells, and the balance of life shifts. The deep sea may seem distant, but its health is our own. If it collapses, the surface world will follow. But amid these warnings, there is wonder. Creatures that glow like stars, forests of tube worms swaying in black currents, snailfish dancing where no human should survive. Each discovery is a reminder that Earth is not yet fully known. Even today, each new dive brings back species never seen before. Some of these organisms produce chemicals that may hold the cures to human diseases, from cancer to infections. Others inspire engineers to design new materials, machines, and even spacecraft. Nature, in its darkness, is still our greatest teacher. And what of the future? One day we may send permanent stations to the seafloor, outposts to study and harvest responsibly, perhaps even to live. Just as we dream of colonies on Mars, the abyss could host human habitats, shielded from storms, radiation, and surface conflicts. The technology to survive in the deep could teach us how to endure in space. And maybe in centuries to come, humanity will look back and realize that our first step towards the stars began not above, but below. This is why we explore: to understand, to protect, and to dream. The deep ocean is not an alien world. It is our world, hidden and waiting. And every dive brings us closer to knowing who we are and what life is capable of. Before we continue deeper into these mysteries, remember to subscribe to StarSky Science. Your support helps us keep uncovering the hidden frontiers of Earth and beyond. So as we drift across the abyss, past the whale falls and vent fields, past the trenches and their ghostly inhabitants, one question rises again and again. If life can survive here, in the crushing dark, where else in the universe might it also thrive? And that is the greatest mystery of all.
We leave the crushing trenches behind, but not the questions they inspire. If life can endure under pressures that would flatten a tank, then perhaps the limits of biology are far greater than we ever imagined. Every fragile snailfish, every glowing jelly, whispers of a possibility beyond our own world. And so, when we look up to the night sky, we carry with us the lessons of the deep. The oceans beneath Earth's surface are vast, yet they are not unique. On Europa, a moon of Jupiter, an icy crust hides a liquid sea deeper than all of Earth's oceans combined. Geysers erupt from cracks in the ice, spraying water into space. When the Hubble Space Telescope captured those plumes, it was as if the moon itself was waving to us, inviting exploration. If our planet's darkest trenches can harbor thriving life, then Europa's abyss may be alive as well. Saturn's moon Enceladus tells a similar story. Cassini's spacecraft flew through its icy plumes and found organic molecules, salts, and the building blocks of life. Imagine hydrothermal vents on Enceladus's seafloor, warm chimneys surrounded by alien tube worms, or perhaps something stranger, something beyond our imagination. To dream of such places is not to indulge in fantasy. It is to follow the evidence. Our own planet has shown us the way. But even as we extend our imagination outward, we must not ignore what is happening here, at home. The oceans we depend on are changing. Temperatures are rising. Acidification is dissolving the very shells of plankton and corals. Oxygen levels are dropping, creating expanding dead zones where life can no longer breathe. And as ice melts on land, the seas rise, reshaping coastlines and threatening cities. The same deep currents that regulate Earth's climate are slowing, disrupted by warming and fresh water. The abyss is not immune. Even its eternal darkness feels the touch of our actions. This is the paradox of the ocean. It is at once eternal and fragile, powerful and vulnerable. It has shaped life for billions of years, and yet in just 2 human centuries, we have placed it in peril. The same abyss that may hold the key to life in the universe now depends on us to protect it. If we fail, the cost will not only be measured in lost species, but in a planet less able to sustain us. And yet, there is hope. Around the world, scientists are uncovering new ways to heal the ocean. Marine protected areas are expanding, giving ecosystems space to recover. Innovative technology is tracking currents, mapping seafloors, and restoring reefs. Even in the abyss, robotic explorers are cataloging life before it is lost, documenting the unseen so that it is not forgotten. Each discovery carries with it the weight of responsibility. We cannot save what we do not know. Perhaps the greatest gift of the deep is perspective. When we look into its black waters, we are reminded of how small we are, how little we understand, and how miraculous life is. The abyss does not care for our borders, our politics, our conflicts. It simply endures.
to protect it is not only an act of science, it is an act of humility. Think of the creatures we have met, the lanternfish carrying light in the darkness, the giant squid, once myth, now reality, the ghostly snailfish, fragile yet unbroken in the hadal trenches. They are not just curiosities, they are symbols of resilience. They remind us that survival is not about dominance, but about adaptation. If we are to endure on this planet or any other, we must learn the same lesson. Technology will be our ally in this. Submersibles that can dive deeper and longer, satellites that can read the oceans from orbit, sensors that can track changes invisible to the eye. Together, they form a bridge between the surface and the abyss. But technology alone is not enough. Knowledge must be paired with wisdom, exploration with restraint, curiosity with responsibility. In the years to come, we may see the rise of deep-sea mining, drilling, and industrial expansion into the last untouched frontier. Companies argue that the minerals of the abyss are essential for a green future, powering electric cars and renewable grids. But we must ask, what price will we pay? Will the pursuit of progress erase ecosystems that have existed unchanged for millions of years? Or will we pause, learn, and choose a different path? Here is where you, the viewer, play a role. Knowledge is the first step toward change. The more people who understand the deep, the more voices will rise to defend it. And so I remind you again, subscribe to StarSky Science. Stay with us as we continue to uncover the hidden worlds of our planet and beyond. Your voice, your awareness matters. Now, imagine again the alien oceans of Europa and Enceladus. Imagine the crushing black of the Mariana Trench. Imagine a hydrothermal vent where red plumes of tube worms sway in chemical storms. Across all of these, one truth connects them. Life finds a way. Whether in sunlight or starlight, heat or ice, pressure or vacuum, life bends but does not break. The ocean is proof. Perhaps one day when we send a probe beneath Europa's ice, we will see a glowing creature swim past its camera, just as the Trieste once glimpsed movement in the Marianas Trench. Perhaps one day, humanity will look into the eyes of alien life and see something familiar, a spark that began in darkness, as it did here. And in that moment, we will understand that Earth's oceans were never just ours. They were a message, a guide, showing us what is possible in the universe. Until then, the deep still calls. Every descent is a reminder that wonder lies just beneath us, waiting. And every ascent back to the surface is a reminder that the future of this wonder depends on what we choose today. So, as we close this part of our exploration, hold on to this truth. The ocean's greatest secret is not the strange creatures or the alien landscapes. It is the resilience of life itself. That resilience is now in our hands to protect. And perhaps in protecting it, we will discover not only the future of Earth, but the destiny of humanity.
The ocean has always been a mirror of Earth's future. But what happens when we look ahead? Not just centuries, but millions of years. To imagine this is not science fiction. It is to extend the patterns we already see, the geological rhythms and evolutionary dances that have shaped our planet since its birth. In the short term, the oceans will warm. The Arctic ice, once a permanent shield, will become a seasonal memory. Rising seas will swallow low-lying lands, forcing millions of people to move inland. Coastal cities will build walls, but the ocean will find its way around them.
The delicate balance of currents, driven by temperature and salinity, may shift, slowing the great conveyor that carries warmth across the globe. Without it, Europe may cool while the tropics grow hotter still. The abyss, though vast and timeless, will not be untouched. Changes at the surface ripple downward. A warmer ocean holds less oxygen, and the slow heartbeat of deep circulation could falter. In that silence, life may vanish. But not all will perish. Life adapts. Creatures will shrink to conserve energy. Bacteria will evolve new ways to thrive in acidic waters. Jellyfish, already survivors of past extinctions, may rise as dominant forms once more, their translucent bells filling seas that once teemed with fish. The ocean of the future may shimmer with strange new dominions, fragile yet resilient. If we stretch further ahead, tens of thousands of years, the ice sheets may grow again. Earth's climate swings in cycles, driven by the tilt of our planet, the wobble of its axis, and the rhythm of its orbit. Warmth yields to cold, seas retreat, and land bridges emerge where water once ruled. In those glacial times, ocean life contracts, yet the abyss remains. The trenches do not care for ice ages. Down there, eternal darkness holds steady. It is a reminder that while the surface shifts like a restless dream, the deep endures like stone. Millions of years onward, the continents themselves will change. The Atlantic, still widening, will one day slow. Subduction zones will consume it, and the Americas may drift back toward Africa and Europe. A new supercontinent will form, and with it, a new ocean. The Pacific, vast and ancient, will vanish, swallowed by the grinding of tectonic plates. Imagine it, one ocean gone, another born. The abyss we know today may be sealed forever, and in its place, new trenches will open. Life, forced into exile, will recolonize the newborn sea. Evolution will write new chapters, sculpting forms stranger than we can picture. Speculative biologists imagine creatures with crystalline skeletons evolved to withstand pressures greater than any known trench. They picture photosynthesis abandoned in favor of chemosynthesis, as surface light grows unreliable under future atmospheres. Perhaps entire ecosystems will depend on heat from below rather than light from above. In such a world, giant filter feeders might sweep chemical clouds near hydrothermal vents, while predators with sonar-like senses stalk the darkness. Eyes may become obsolete. Light, once a guide, will fade to irrelevance. Evolution favors the practical, and in a world of stone and pressure, vision may simply be a guerdon. And what of us? Humanity may be forced to adapt to the deep. If surface life becomes hostile, if the air grows too hot, or the storms too violent, then the abyss may become refuge. With technology, we could build cities on the seafloor, domes anchored to basalt ridges, lit not by sunlight but by artificial suns. Already, engineers dream of mining manganese nodules scattered across the abyssal plains, black lumps of metal that could power industries for centuries. If mining becomes habitation, then perhaps our descendants will live there, where today only robotic probes wander. Entire generations may be born under pressure, their lives defined by oceans that once terrified their ancestors. Such a future raises a haunting question. Would we still be human? Over countless generations, adaptation may reshape us. Larger lungs, denser bones, resistance to nitrogen and carbon dioxide. The abyss would sculpt us as surely as it sculpts fish. We may become a new branch of life, born of necessity, carrying with us the last memories of the surface. Imagine a civilization that calls the abyss home, its myths not of sky and stars, but of vents and currents. To them, the surface may become legend. The stars, invisible through kilometers of water, may be forgotten. Humanity, in becoming eternal, might also become alien to itself. But perhaps long before that, we will leave. The oceans of Earth are only the beginning. If we build machines that can withstand the Mariana Trench, then we build machines that can withstand Europa's abyss or Enceladus's buried sea. The skills we hone here may be the skills that carry us outward. Just as the Polynesians once spread across the Pacific in fragile canoes, guided by stars and memory, so too may our descendants spread across the oceans of the solar system. The ocean is not only our past, it is our passport. Yet Earth's story will not pause for us. Hundreds of millions of years from now, the oceans may vanish. As the sun brightens with age, more water will evaporate, climbing into the sky, broken apart by solar winds, its hydrogen lost to space. Earth, once blue, will turn barren. The abyss will dry into rock. The creatures that once glowed in its blackness will be fossils, buried beneath the dust of a dead sea. Our world will resemble Mars, its oceans nothing more than scars. But do not mistake this for tragedy. The ocean is a chapter, not the book. Its story is bound to the cosmos. When Earth's seas are gone, other oceans will remain. Under Europa's crust, within Titan's methane lakes, beneath the icy mantles of exoplanets far beyond. If life has sprouted here, then surely it has sprouted there. And so though Earth's waters may fade, the cosmic sea will endure. As we return to the present, let us remember this. The abyss is not only a place, but a teacher. It shows us resilience, fragility, and the scale of time itself. Every creature that flickers in its depths is both ancient and new, carrying billions of years of survival in its genes. When we study them, we study the possibilities of life itself. And so I ask again, if you have not yet subscribed to StarSky Science, do so now. Join us as we continue to explore the hidden truths of our world and the wider universe. Because the ocean story is not just for scientists or explorers, it is for all of us. The future Earth may be a planet of ice or fire or dust, but in every version, the lessons of the deep will remain. They remind us that survival belongs not to the strongest, but to the most adaptable, that beauty can thrive in darkness, and that even in silence, life finds a way. As we return to the present, let us remember this. The abyss is not only a place, but a teacher. It shows us resilience, fragility, and the scale of time itself. Every creature that flickers in its depths is both ancient and new, carrying billions of years of survival in its genes. When we study them, we study the possibilities of life itself. And so I ask again, if you have not yet subscribed to StarSky Science, do so now. Join us as we can.
The stars above us are not empty. They are scattered with oceans. Oceans we cannot yet see, but which we know must exist. Our own solar system hides them well, beneath shells of ice, beyond our reach, yet tantalizingly close. If we have learned one lesson from Earth's abyss, it is that life thrives where it should not. Darkness is not death. Pressure is not absence. And so, when we look outward, we must ask, where else has the deep written its story? On Europa, a moon of Jupiter, an ocean larger than all of Earth's combined lies locked beneath a crust of ice. Tides pulled by Jupiter's gravity stir it endlessly, keeping it liquid, restless, alive with energy. At the bottom of that alien sea, vents may spew warmth, just as they do in Earth's trenches. And if so, then life may gather there, perhaps microbial, perhaps more. Imagine creatures shaped not by sunlight, but by the dance of heat and mineral. Perhaps translucent beings drift in the dark, feeding on chemical clouds. Perhaps predators lurk, blind but sensitive to vibrations. The ocean does not need light, it only needs possibility. Enceladus, Saturn's icy moon, offers another promise. Geysers erupt from its south pole, spraying water into space. When probes fly through, they detect organics, the chemistry of life flung into the void. Somewhere beneath that shell of ice lies another ocean, salty and deep. To stand there, watching the plumes rise, is to look at a living hint, a whisper that says, life may not be rare at all. It may be common, hiding in the cold shadows where no sunlight reaches. Then there is Titan. Its lakes are not water, but methane. Its rivers not carved by rain, but by liquid hydrocarbons. To us it seems alien, yet to life shaped differently, it may be home. Imagine organisms whose cells do not depend on water, but on liquid methane. Imagine chemistry that works in ways unfamiliar to us. The deep teaches us humility, that our way of life is not the only way. Titan may be proof of that. And beyond our solar system, the numbers expand into infinity. Exoplanets discovered orbiting distant stars already suggest oceans. Some worlds are so close to their stars that oceans may boil and steam into endless clouds. Others, farther away, may be completely frozen. But among them are water worlds, planets covered entirely by ocean. No land, no mountains, just endless waves. What would life look like there? With no shallow seas, no coastlines, perhaps intelligence would arise from creatures who never touch land. Perhaps civilizations would drift in floating hives, their histories told not on stone, but in currents. A water world could be alive with minds that never see the sky. And so, the abyss of Earth is not unique. It is a model. It is the first chapter of a far larger story. Every trench on our planet may be echoed in the galaxy, every vent mirrored in alien seas. To explore the deep here is to prepare for the deep beyond. Humanity will not always be bound to Earth. Already we build machines to dive where we cannot go. In time, we will send them not only into our trenches, but across space. Imagine a submersible sinking into Europa's waters, cutting through ice, dropping into darkness. Its lights reveal movement. A shadow stirs, and for the first time, we see a creature that evolved on another world. That moment will change us forever. Not because we found life, but because we understood it was never ours alone. If we survive long enough, we will walk among stars, Not on land, not under sky, but beneath alien seas. The abyss will become our constant, and just as sailors once mapped Earth's oceans, so too will our descendants map the seas of other worlds. The Milky Way itself may become an archipelago of oceans, each world another island in an endless cosmic sea. But time moves forward, and nothing lasts forever. Stars age, galaxies collide. In billions of years, even the oceans of Europa and Enceladus will vanish, boiled away as the sun swells into a red giant. Water, the softest substance, will face the hardest truth: impermanence. Yet in that loss, there is continuity. Water will form again in new systems, around new stars. Oceans will rise again, and perhaps life, as stubborn as always, will return. What matters is this: the abyss is eternal not because one ocean lasts forever, but because there will always be another. The cosmos is a sea scattered with drops of liquid possibility. To study Earth's depths is to glimpse the pattern written across the universe. And so, to everyone listening now, if you have not subscribed to StarSky Science, I invite you to do so. Join this voyage not just through space, but through time, through imagination, through the profound reality of existence itself. Because each new discovery, each new world is a reminder that we are part of something larger. The oceans within us, our blood, our cells, our chemistry, are echoes of the sea we came from. And those seas, in turn, are echoes of cosmic oceans, the hydrogen and oxygen forged in the hearts of ancient stars. When we look at the deep, whether here or far away, we are looking at our own origin, and perhaps at our destiny. The universe is waiting, its oceans are waiting, and we will answer. If oceans exist on alien moons and distant planets, what happens when we stretch our imagination farther, into the deep future of the universe itself? What becomes of water, of seas, of life, when stars themselves begin to fade? The story of the abyss does not end with Earth, or even with our galaxy. It continues, written across billions of years, through collapse, rebirth, and silence. The oceans we know today are temporary. Their tides are pulled by a moon that is slowly drifting away. Their basins are carved by tectonics that will one day stop. In the far future, Earth's seas will vanish, boiled away as the sun swells into a red giant. Imagine standing on the last shoreline, the horizon cracked and dry, the air shimmering with heat. No waves, no salt, only the ghost of an ocean that once covered the world. For life on Earth, that is the end. But for water, for the idea of the ocean, it is only another transformation. Because water is forged in stars. Every droplet traces back to hydrogen and oxygen, born in nuclear furnaces billions of years ago. When one world's oceans vanish, new ones will form around younger stars. Even as the Milky Way collides with Andromeda, even as galaxies tear each other apart, the chemistry of water will reassemble. Oceans will rise again, not here, but elsewhere. This is the great resilience of the cosmos, not permanence, but renewal. But let us ask a harder question. What happens when stars themselves die, when the universe ages past its bright youth? Scientists call this the era of degenerate matter, when only white dwarfs, neutron stars, and black holes remain. In such a universe, oceans as we know them cannot exist. The warmth of starlight will be gone, and without heat, liquid water cannot survive. Yet the abyss teaches us never to underestimate life. Could there be other kinds of oceans? Oceans of energy? Oceans of particles, where life might still endure? Black holes are often imagined as voids, but they are more like strange seas. Around them, space-time itself swirls like water down a drain. Matter falls inward, heating, glowing, becoming an accretion disk of incredible power. To some scientists, these violent rims of energy are like cosmic shores, boundaries where physics bends and extremes gather. Could something live there? Not life as we know it, but perhaps patterns of information, entities that feed not on chemistry, but on gravity itself. If Earth's abyss teaches us anything, it is that where energy flows, life may follow, even near the maw of a black hole. And then there is the ocean of information. Stephen Hawking once said that black holes are not truly black. They emit radiation, a slow leak of energy. If so, then information is never truly lost. It is encoded, rippling outward, faint but eternal. Imagine civilizations that learn to ride those ripples, to decode the whispers of collapsed stars. In the silence of the far future, they may swim in seas of pure data, preserving memory long after biology has ended. But let us come back to a nearer horizon, the collision of galaxies. In 4 billion years, the Milky Way and Andromeda will merge. To us, it would be a cosmic storm, stars slung like waves, black holes colliding, worlds torn apart. Yet within the chaos, new systems will form. New stars, new planets, new oceans. From destruction, creation. Just as deep-sea vents bloom after volcanic fury, the merging of galaxies may bloom with fresh seas, fresh chances for life. There is something profound in this symmetry. On Earth, the abyss is born from destruction, tectonic rifts, volcanic heat, crushing pressure. Yet it becomes fertile, a cradle for strange life. On the cosmic scale, galaxies collide, stars explode, black holes devour. But even then, the pattern holds. From violence comes oceans. From chaos comes life. Now imagine a future where humanity, or whatever we become, survives long enough to see it. Not bound to Earth, not even to the sun, but scattered across many worlds, adapted to alien seas. We may learn to harvest black hole energy, to swim in radiation fields, to send our minds across quantum networks like currents in a vast digital ocean. The abyss will evolve. From water to energy to information. Each stage stranger, but each still carrying the essence of survival. Yet even that future has an end. The universe will continue to expand. Stars will die. Black holes themselves will evaporate over unimaginable timescales. At last, there will only be darkness, cold, and silence. No oceans, no waves, only the final stillness of space. And yet, listen closely, even here possibility lingers. Some theories suggest that in the far, far future, quantum fluctuations may spark new universes, new beginnings. If so, then the ocean is never truly gone. It simply waits to rise again in another cosmos, another abyss, another stage where life, against all odds, may play again. For us, here and now, this is more than speculation. It is a reminder. a reminder that the abyss is not emptiness, it is transformation. That oceans, whether of water, fire, gravity, or data, are the universe's way of teaching us resilience. We survive not by clinging to one shore, but by learning to swim in every sea. And so, as you listen, I ask once again, if you have not yet subscribed to StarSky Science, take a moment to do so. Join us as we continue exploring the mysteries of existence, from Earth's deepest trenches to the farthest horizons of time. Because the story is still unfolding, and together we can witness its chapters as they are revealed. The abyss has always been our teacher. It shows us that life is stubborn, creative, unafraid of darkness. Whether in Earth's deep trenches, Europa's hidden seas, or the swirling rims of black holes, the lesson is the same. Survival is not the exception. It is the rule. So when we ask, what is the future of oceans? The answer is both humbling and vast. They will vanish, and they will rise again. They will change, and they will endure. In one form or another, the ocean is eternal. And perhaps so are we.
For billions of years, the ocean shaped us. It cradled the first spark of life, sculpted our bodies, our myths, our civilizations. But in the deep future, could we become the ones who shape the ocean instead? Could humanity itself transform, not only to survive in alien seas, but to become part of them? On Earth, our relationship with the sea has always been double-edged. It has fed us, inspired us, terrified us. Sailors once looked out at endless horizons, believing monsters lived beyond the edge. Today, we peer into the deep trenches, still finding creatures that seem drawn from nightmares. But the future will demand something new. The oceans of Earth will not remain as they are. Climate change, shifting continents, and eventually the swelling of the sun will reshape them. Seas will rise, then evaporate, leaving a barren shell. If we are to survive, we must learn to adapt to oceans beyond Earth. Scientists already suspect that oceans hide beneath the icy shells of moons, like Europa and Enceladus. To live there, we cannot remain the same fragile beings we are today. Imagine explorers descending through kilometers of ice, emerging into vast black waters lit only by the glow of alien hydrothermal vents. Their suits would be less like clothing and more like second skins, engineered symbioses of biology and technology. Over time, evolution might blur the line further. Gills integrated into human physiology, skins resistant to crushing pressure, eyes tuned to bioluminescent light. The first generation may use machines, the second, genetic engineering, the third, something unrecognizable, a human anemone hybrid, a descendant who no longer walks on land but drifts in alien tides. Would they still call themselves human? That question will haunt the future. For us, humanity is defined by memory, language, culture. But cultures evolve, as environments do. On Europa, religion itself may reshape around the ocean. The abyss would no longer be a metaphor. It would be home. Imagine prayers whispered not to the sky, but to the trench. Imagine myths told of glowing creatures as ancestors, as messengers, as gods. In such worlds, the human story would not end. It would branch. Meanwhile, others may reject biology altogether. On distant planets with boiling seas or toxic atmospheres, survival may depend not on flesh, but on machines. Floating cities drifting on methane oceans, artificial minds encoded in swarms of nanobots, shaping waves like thoughts. Here, humanity becomes liquid in another sense, fluid consciousness rippling across digital seas. To future historians, this might be the true second oceanic revolution, the day when life left not the land for the sea, but the body for information. Yet even in that strange future, memory of Earth will remain. Ancient humans looked at the sea and saw eternity. Future humans, no matter how changed, may look at alien oceans and feel the same. This continuity of awe, of fear, of reverence may be the last thread tying us to our origin. But let us return to something more immediate. Today, our own seas are changing faster than we ever imagined. Coral reefs bleaching, fish populations collapsing, coastlines drowning beneath rising tides. In the year 2100, parts of Earth may already resemble alien worlds. Salt flats where oceans once rolled, cities half buried under relentless water. And here's the paradox. To prepare for the cosmos, we must first survive our own changing planet. The technologies we build now, floating habitats, genetic adaptation, closed-loop underwater farming, may not just save us here, but serve as prototypes for survival beyond Earth. Some scientists have even suggested creating new oceans, terraforming Mars, melting its poles, flooding its basins. Imagine watching a new sea slowly expand across the red desert, clouds forming for the first time in billions of years, rain falling on lifeless rock. It would not be the ocean of Earth, no fish, no whales, but it would be water. It would be waves. It would be a place where human children could one day swim under alien constellations. But with new seas come new dangers. The creatures of Earth's abyss remind us, evolution never wastes an opportunity. If life already lurks beneath the ice of Europa or in the methane lakes of Titan, we will not arrive alone. We may meet ecosystems millions of years older than ourselves. The question will not be whether we can survive, but whether we can coexist. To them, we may appear as invaders, predators, parasites. The ethics of colonizing oceans will be as complex as the science. Will we respect alien seas as sacred, or will we repeat the mistakes we made on Earth? And yet, humanity's gift has always been imagination. We imagine ships before we build them. We imagine stars before we reach them. Perhaps the most powerful adaptation we carry is not biological or technological, but cultural. The stories we tell shape our survival. In the deep past, sailors told stories of sea serpents, of leviathans waiting at the edge of the map. Today, we tell stories of exoplanets, of liquid worlds orbiting other suns. Tomorrow, those stories may become real. And when they do, they will guide us. So, what does it mean, truly, to become an ocean species? It means surrendering the illusion of control. On land, we build walls, roads, cities. The sea resists such order. It shifts, it drowns, it erases. To live in the ocean is to accept uncertainty, to dance with chaos. A future humanity adapted to oceans, biological, digital, or cosmic, may carry this philosophy deep in its culture.
They may see time itself as a tide, identity as a current, death as a return to the sea. Perhaps that will be our final transformation, not just bodies fit for the abyss, but minds that embrace its mystery. For now, we stand at the threshold. Our oceans are threatened, our planet fragile, our species uncertain. Yet we have never been more capable of imagining, of reaching, of transforming. The abyss ahead is not an end, it is an invitation. If you've listened this far, take a moment to subscribe to StarSky Science. Together, we will keep asking the questions that matter, not just where life is, but what it could become. Because the ocean is not just out there, it is within us. We are, in a very real sense, walking seas. Salt water coursing through veins, tides of thought rising and falling in the brain. And perhaps, in the end, the greatest mystery is not whether we can adapt to future oceans, but whether we are already one.
Imagine this, not just living in the ocean, not just adapting to it, but becoming it. What if, in the farthest reaches of time, humanity no longer existed as separate beings, but as something vast, fluid, and interconnected, a living sea of thought? This idea may sound like pure fantasy, but consider this. Life began in the ocean, as molecules drifting together, forming patterns, networks, codes. Over billions of years, those codes became cells, then organisms, then societies. Each step forward created higher levels of complexity, higher levels of connection. What if the next step is no longer the individual, but the collective? Not a mind in a body, but an ocean of minds, flowing, merging, dividing like currents. Some scientists already see hints of this possibility. Neural networks, both biological and artificial, resemble rivers of information. Our brains are 70% water, with electrical impulses rippling like waves across neural seas. And now, in the digital age, billions of humans are linked through networks so vast they echo ecosystems. One could argue that we're already drifting toward becoming something oceanic, a species whose consciousness is less like a flame and more like a tide. Now, imagine taking this a step further. On an alien world beneath an endless black sea, our descendants may learn not to fight the abyss, but to dissolve into it. Bodies would no longer be rigid, but fluid. Organisms could merge, exchange information directly, split apart, then merge again. Identity would become porous. You would not be a single you. You would be a current in a larger sea. Memory itself could move like plankton, carried from one being to another, until the idea of individuality fades. Is this terrifying? Yes, but it is also liberating. Because in such a state, loneliness would vanish, war would vanish, even death would lose its meaning, because the current continues, even as drops disperse. Some thinkers are already wondering if alien oceans could be alive in exactly this way. Imagine Europa's hidden waters. For billions of years, they have remained sealed, undisturbed. If life exists there, it may not look like a fish or a squid. It could be the ocean itself, a single planet-wide organism aware in ways we can't imagine. Its currents could be its thoughts, its chemical exchanges, its memories. Every wave, a whisper. Every bubble, a dream. If we ever encounter such a being, what would we say? Could we even communicate? To an alien mind, we may seem like sparks, brief, rigid, inflexible. To us, it may seem like a god, infinite, ancient, impossible. But perhaps communication would not be words at all. Perhaps it would be immersion. to know the alien ocean, we may have to let go, to dissolve, to drift into its currents. Would you surrender yourself to such a sea, knowing you might never return as you? This is where science meets philosophy. If individuality is just a temporary pattern, then perhaps dissolving into something larger is not an end, but an expansion. We already carry the ocean inside us, in our blood, in our tears, in the rhythms of our hearts. To merge with a cosmic sea might only be the final return. Some scientists at NASA have speculated that the most common form of intelligence in the universe may not be individual creatures like us, but vast collective systems. Planets where the biosphere itself wakes up, oceans where awareness spreads like a tide, even stars whose magnetic fields might one day be seen as neural networks of cosmic scale. If that is true, then perhaps we are the outliers, brief, lonely sparks in a universe of endless seas. But what if we are meant to join them, to become a galactic ocean, a mind spanning not just worlds, but entire solar systems? It sounds unthinkable now, but so did flight to the first humans, so did space travel to our grandparents. Perhaps consciousness itself is like water. It always seeks to flow, to connect, to expand until there are no barriers left. In that distant future, human may no longer mean 2 arms, 2 legs, a single body. It may mean a wave in a larger sea. Our stories, our memories, our science, our love, all drifting together, forming an ocean that never dies. If you've come this far, take a moment to subscribe to StarSky Science, because what we are exploring together is not just science, but the possible futures of consciousness itself. Every subscriber is another ripple, another drop in this growing ocean of curiosity. And so we must ask, when we look at the seas of Earth today, at the crashing surf, at the swirling deep, at the trenches where sunlight never falls, are we not looking at a mirror? A mirror of what we came from and perhaps what we are destined to become. The ocean does not end. It transforms, it moves, it rises, it falls, and so will we. One day, perhaps billions of years from now, when Earth's oceans have boiled away, when the sun has swollen and burned, when the last stars flicker in a darkened universe, something will remain. A sea not of water, but of thought. A tide not of salt, but of memory. An ocean that is everywhere and nowhere all at once. And if you listen closely across that infinite silence, you may hear it whisper back the oldest truth of all. We are water. We are waves. We are the ocean, dreaming of itself. So as we leave the depths behind, remember this. The ocean is not just water. It is time. It is memory. It is the living archive of Earth and perhaps the blueprint of life across the cosmos. From the smallest trench to the mightiest tide, from alien seas beneath frozen moons to the possibility of entire planets dreaming as oceans, one truth echoes: we are never separate from the sea. It shaped us, it sustains us, and perhaps in the farthest future, it will absorb us back, not as individuals, but as part of something greater, endless and eternal. We began as drops. We may end as tides. And in between, we are the wave. This is StarSky Science. If you've stayed with us through this journey, make sure you subscribe, because the story of our planet, our universe, and our place within it is far from over. The next discovery could change everything. Until then, look at the ocean with new eyes, because every wave you see, every current you feel, is not just water. It is a reflection of the universe itself and of you. You've just explored the unknown with us, and there's so much more waiting to be uncovered. Make sure to subscribe so you never miss the next discovery that could change the way we see our world. This is StarSky Science, where the universe speaks
and we listen.